वेलकम बैक टू माय चैनल गाइस। तो आज हम प्रोसीजर आर्किटेक्चर के यूनिट 1 के सारे पीवाईक्यूज देखेंगे। सो लेट्स स्टार्ट। सो फर्स्ट क्वेश्चन है, एक्सप्लेन प्रोग्राम मेमोरी ऑर्गेनाइजेशन ऑफ PIC 18 माइक्रोकंट्रोलर विद सुटेबल एग्जांपल। So PIC microcontroller follows Howard architecture, meaning it has separate memory for programming instruction and data memory for data storing. So the program memory is used to store the instruction code that microcontroller executes. Programming, let's see, program memory. It is a flash memory. It's a non-volatile, meaning what? अगर पावर नहीं है वहां पे, इफ माइक्रो कंट्रोल में पावर भी नहीं है, पावर कट ऑफ है, फिर भी डाटा उसमें स्टोर रहेगा, हमारा प्रोग्राम उसमें स्टोर रहेगा. Stores the main program code, interrupt routines and configuration settings. The size of a program memory of PIC 18 is vary 2 KB से 200 128 KB के बीच में lie करता है. Let's see parts of program memory. It is divided into multiple section as follows. ठीक है. First one is reset vector. So जो when uses microcontroller start और reset, so base location जो होती है वो यहाँ से शुरू होती है. तो इसका base address है 0x 6 times 000. यहाँ पे देखिए. Second one part is interrupt vectors. So interrupt vector, what means PIC 18 has two interrupts. First one is high priority interrupt vector and low priority interrupt vector. So address of a high priority interrupt vector is 0x00008 and low priority vector का last में 18 है. So when interrupt occurs, the microcontroller jumps to this location to execute the respective interrupt service routine. ठीक है. Next question is, what is draw and explain status register of PIC 18 microcontroller. So here's the next question. Draw status register of PIC 18 microcontroller. So PIC status register is a 8-bit register that indicates the arithmetic operation or processor. Basically, it is used for the decision making and conditional loops. ठीक है. So जहाँ पे loops और decision making होती है वहाँ पे use होता है. So status register का format देखिए. 8-bit structure of status register. हमें पहले boxes निकालना है. So 0, 3, 4 और 6, 7 बॉक्स में पैरामीटर्स पुट करें. बाकी इसमें हमें वैन में स्पेस छोड़नी. सो सी 0 में सी, 3 में कैरी फ्लैग, इसमें डिजिट कैरी फ्लैग, और इसमें 0 यहाँ पे ओवरफ्लो और 7 में नेगेटिव. सो 1 कैरी. इफ रिजल्ट हैज अ कैरी इन एडिशन और बोरो इन सब्सट्रैक्शन, सो कैरी इज इक्वल टू 1. एग्जाम्पल 255 प्लस 1, यहाँ पे कैरी हो रहा है तो c इज इक्वल टू 1. डिजिट कैरी फ्लैग यूज इन BCD अरिथमेटिक. इफ कैरी occurs when from a 3-bit to 4-bit, DC is equal to 1. एग्जाम्पल 9 प्लस 7, इसको हमने BCD में कन्वर्ट किया तो ये आता है 100 प्लस 011. इसमें कैरी आता है इसलिए DC इक्वल टू 1. इफ जीरो फ्लैग देखिए, इफ रिजल्ट ऑफ द ऑपरेशन इज 0, then z is equal to 1. Example 5 minus 5 is equal to 0, then z is equal to 1. Overflow means only for sign numbers. Sign numbers क्या होते हैं? तो there is a range of sign number -1 to 8 to 1 to 7. So int जो होता है वो अगर साइन वैल्यू रही तो ये इसकी रेंज रहती है. अगर इसके बाहर चला गया नंबर तो ओवरफ्लो हो जाएगा. ठीक है. नेगेटिव फ्लैग यूज इन साइन नंबर्स. If the result is negative, n is equal to 1. Example 1000 0000. So -128 is a complement. ठीक है. How status registers are used in programs. So use in conditional branching, you helps in error checking and debugging, use in arithmetic operation, use in decision making, in for loops, conditional statements. Example क्या है? MOVLW 0x005 load with 5. ठीक है. Subtract the sub LW. ठीक है. और ये स्टेटस रजिस्टर z इक्वल टू 1, रिजल्ट इज 0, c इज इक्वल टू 1, नो बोरो. ठीक है. नेक्स्ट क्वेश्चन है, व्हाट इज वॉचडॉग टाइमर यूज इन PIC 18. microcontroller. ठीक है. Explain watchdog timer using PIC microcontroller. Explain watchdog timer. ठीक है. Watchdog timer क्या है? Let's see with an example. Have you ever seen oven, microwave, or induction? There is an inbuilt timer is there, which when timer is set and it reach to a specific time, it automatically get off. जो इंडक्शन में वो जब उसके टाइम को रीच हो वो ऑटोमेटिकली ऑफ हो जाता है. तो व्हाट द टेक्नोलॉजी इज अ वॉचडॉग टाइमर. लाइक इट्स अ सेल्फ रिसेटिंग timer that prevent a microcontroller from getting stuck due to software errors. If the program fails to reset a watchdog timer within a specified time, the system might automatically reset to restore the normal operation. So yes, so now we will see the working. Okay, so working यहाँ पे यहाँ पे पहले क्लॉक रहता है, वॉच डॉग टाइमर को जाता है. वे अगर रीसेट सीपीयू करता है अगर टाइमर को रीच हो गया, और ये सीपीयू की क्लॉक भी इसमें इनबिल्ट रहती है. ठीक है. सो इट स्टार्ट रनिंग व्हेन अनेबल्ड, ऑटोमेटिकली गेट अनेबल्ड व्हेन वी स्टार्ट the program reset the watchdog timer using the this instruction CLRWDT clock watchdog timer. If not clear in time, then the watchdog timer reset the microcontroller automatically. So it's basically automatic restart system that ensures the PIC18 keeps running smoothly. Features of the watchdog timer: independent timer, runs separately from main clock, and configure timeout ranges from 4 minutes to 68 seconds using a poster scale. Low power consumption, ideal for battery operated devices, prevent system crashes. Independent timer, configure timeout, low power consumption, and prevent LCLP. So here is example. while हमने वहाँ पे वन दिया पैरामीटर. So यहाँ पे मेन प्रोग्राम की लूप, और ये रही इंस्ट्रक्शन. If clears the watchdog timers to prevent a reset. If clock the watchdog timer is not executable, then microcontroller resets automatically. Importance इसका है कि prevent system crashes due to failure, system failure, ensures the high reliability and MDES system. ठीक है. And reduces manual intervention by auto resetting. So ये automate कर देता है सभी चीज़ों को, and safety precautions यहाँ पे लिए जाते हैं. Save the time maintenance by keeping the system running smooth. So write neat diagram and discuss detail about architecture of PIC18. So PIC18. So architecture of PIC18, you have to recite this diagram and draw it as you like. It has T0, T1, T2, CPU, instrument, instructions. Then this whole diagram you have to recite by yourself, and I will explain the diagram. So the PIC in architecture compromises of its contains CPU input output ports, memory organization, AD converter, timers, interrupt, serial communication oscillator, and CCP module, which are discussed in detail. So first one is CPU, Central Processing Unit, PIC microcontroller. Uh, CPU consists of ALU, CU, arithmetic logical unit, common unit, and accumulator, control unit, and ALU. It's arithmetic. It's mainly used for arithmetic operation like plus, minus, addition, subtraction, multiplication, division, and logical decision. Memory unit. Memory unit is MU. It is used for storing instruction and after processing. Control unit to control the internal and external peripherals control. Accumulator. The accumulator is used for storing the uh, data. Memory organization. So memory organization module in the PIC microcontroller architecture. It consists of two parts, right? Random access memory and read-only memory and stack. So first of all, speak about random access memory. So is RAM is unstable memory which is used to store the data temporarily in a registers. A memory is a temporary memory. Is classified into two banks. Okay. This explanation will come for 3 to 2 marks, and the diagram which is main way it is you have to recite. Like here, let me explain in very short. This is oscillator, and, and below there is internal oscillator, AID converter, SPI. So this whole diagram we have to recite. There is no option. Okay, so next question is our write short note on brownout reset. So it's a safety feature in the microcontrollers like PIC18 that reset the system when supply voltage drops below or safe level. So it's like Watchdog timers. जैसे Watchdog timer में ऑटोमेटिकली रीसेट होता था वही यहाँ पे भी ब्राउन आउट रीसेट में भी वही हो जाए. So लेकिन वहाँ पे कंसेप्ट क्या था कि एरर सॉफ्टवेयर एरर आ गया तो उस वजह से रीसेट होता था. यहाँ पे वोल्टेज ड्रॉप की वजह से होता है कि वोल्टेज में कई कई बार ड्रॉप आ जाता है उस वजह से यहाँ पे रीसेट हो जाता है. So it prevents an unexpected behavior corruption of data due to low voltage condition. Also it provides safety so that microcontrol do not get corrupted due to low voltage. Its working is uh, if the power supply of voltage drops below present threshold voltage, which is fixed voltage, and then it will automatically circuit detects it and cut down and automatically get reset. The microcontroller reset itself to prevent malfunction. Once voltage returns to the safe level, system restart normally. It's called voltage recovery. Features uh, unpredicted behavior due to low voltage. Uh, Protects memory and program execution from corruption. System performance in power sensitive application. Threshold voltage can be configured in some PIC18 models. Let's see diagram. So here you can see. So here is a supply voltage V1 and V2. So V1 is going, and if it falls, then power get off. Then it's a danger zone. So it start automatically. So this is between graph is between supply voltage and time, and this is power off, and this is a whole diagram of the brownout reset. Question is differentiate between RISC and CISC. So RISC so it stand for RISC मतलब reduce instruction set computer, and CISC मतलब complexity instruction set computer. Reduce and complex set instruction set computer. So RISC executes one instruction per clock cycle, while CISC instruction may take a multiple cycles. It's a simple and limited set of instruction in RISC, while less and complex set of instruction is in the CISC. It requires more memory and RAM memory. It requires less RAM memory. Fixed length instruction. Here variable length instruction easier to implement, harder to implement. Pipelining. It has faster execution. It has slower execution. Low power consumption. High power consumption. Require more lines of codes to perform a task, while in CISC fewer lines of code due to powerful instruction. Simple and cost effective, more complex and costly. Okay, that's it. So our next question, explain data memory organization of PIC18 microcontroller with suitable diagram. So जैसे प्रोग्रामिंग मेमोरी में जो था थोड़ा सा वैसा थोड़ा थोड़ा सेम है. जैसे इट्स PIC18 microcontroller follows Harvard architecture, meaning separate memory for the both data memory and program memory are used so that efficiently we can use it. Data memory is primarily used for storing variables, register, and stack operation. Unlike program memory, it not have any flash memory. It uses RAM for temporary data storage and EEPRAM, which is electrically erasable programmable read-only memory for non-volatile data storage. So let's see the structure of the data memory. Data memory structure consists of GPR, which general purpose RAM, stored temporary variables, and data used in computation divided into a banks for efficient addressing. Uh, Total 15 banks is there, and each bank consists of 256 of uh, bytes of region, and total we have 4096 bytes totally. These 15 banks are divided by 15, so each bank consists of 256 byte region that can access without switching banks. So let's see GPR. So GPR stores a temporarily variable data used in computation, divided into packs efficiently for it. The amount of available RAM varies based on the PIC18 model. Next is SFR, special functions registers. So it's control of peripheral and CPU operations. It includes port A, port B, timer registers, status register, interrupt control register. Next is access bank as a unbanked memory. As earlier I said that a 256 byte region that can access without switching banks. मतलब ये एक ऐसा रीजन है कि वो हम एक्सेस कर सकते हैं मतलब विदाउट स्विचिंग 256 byte of region, and it is position located at 0x00 to 0x0ff in the RAM. Provide faster and to access to frequently used register. Stack memory stores return address for function call and interrupt. Suppose 31 level of nesting. Unlike traditional RAM, it is not directly addressable. And next is fifth structure is EEPROM, non-volatile memory, used to store data such as calibration, constant use preference, and setting, and can be electrically erased and return accessible through EECON01 and EECON2 registers. Now let's see the diagram. So here is the diagram of a memory map. So as I said that it contains of 15 banks. So here is 1, 2, 3, 4, 5. So from bank 0 to bank 6 we use uh, GPR, general purpose RAM, and from 14 to 15 we use SFR. Okay, so this half of the 15 is GFR. Here is GFR, and half of the is SFR. So half is taken from here and half is taken from here, and which combinedly make an access bank. So 96 bytes from bank 0 and 160 bytes from bank 15 combinedly forms a access bank. uh, GPR, half of GPR taken from 0th bank and half of SFR taken from 15th bank. So here it is, and this have to recite. ये थोड़ा सा रट्टा ही मारना पड़ेगा. So that's it. Next question is explain any three modes of PIC18 microcontroller with example. So there are addressing mode with instructions example. Okay, to know the working principle and data handling, we need to have a clear knowledge about addressing modes in PICD. So totally 5 addressing modes are there: immediate addressing mode, register addressing mode, memory operand addressing mode, direct addressing mode, and indirect addressing mode. So immediate addressing mode, in this word the addressing mode, operand is a number or a constant, not as a address. Okay, so here is example: MOVLW MOVL 43H. Here is operand is data, that is 43H, not a address. So in addressing mode, PIC microcontroller data is directly transferred and data is immediate after a opcode. That is why the type of addressing mode is called immediate addressing mode, because it transfers data immediately after the opcode. This is what it is: fast execution. It's a register operand addressing mode. So register is a storage where the address is stored. Um, In this addressing mode, operand is register which holds data to be executed. Register operand addressing mode deals with the registers like CL or D. Next is memory addressing mode. So memory in this addressing mode, the operand is address of memory location which holds data to be executed. So a indirect addressing mode and indirect addressing mode. So addressing is included as a part of instruction. Uh, Indirect addressing mode. Here in F indicates address of a file register. The operand is in the file register RAM data memory. Indirect addressing mode. A register is used as a pointer to an address in the data memory. These are the example of some indirect addressing mode. So it does not take an address from instruction, but it derives from IRP. Address location is accessed through int F register, and int F register in fact holds the address indicated by the FSR. So next question is state features of PIC18 microcontroller. So key features of PIC18 microcontroller. First one is Harvard architecture. So flash memory is there. So if power is cut off, then still you can it do not forget the data or the code which has fed in it. So it is a main feature which used for faster execution also. Then next is high performance CPU. 8-bit reduced information set computer architecture for efficient processing. Then large program for data memory, up to 2 memory of flash memory for storing program, and up to 4 KB of RAM for temporary data storage. EEPROM support a non-volatile data storage also. Then multiple addressing, direct, indirect, index, immediate register. So these are multiple addressing modes. Supports a bank memory architecture for efficient data access. Fifth one is advanced input output features. So multiple general purpose input output pins for interfacing sensors, motors, analog digital converter with up to 12 bit of resolution. 6 is interrupt handling and stack support. Multiple interrupt sources like external internal are supported. Vector interrupt system for faster response. Next is multiple communication protocol. USART for serial communication, SPI, and I2C for device to device communication. Low power consumption supports in power saving mode like sleep mode or ideal mode. Watchdog timer for reliable operation. And in बस I think it इतना sufficient है आपको पेपर में मार्क्स लाने के लिए, so इतना ही लिखिएगा. Next question is with need diagram details of architecture microcontroller. So this question ये question repeated है. हमने पहले भी कवर किया है, लेकिन फिर से हम एक बार देख लेते हैं. सो डायग्राम ही देखेंगे. पिछली बार हमने थोड़ा सा फर्स्ट वन इज ऑसिलेटर, उसके नीचे इंटरनल ऑसिलेटर, उसके बाद एडी कन्वर्टर और वी रेफरेंस, एसपीआई यूएसआरटी, सीरियल कम्युनिकेशन, सीपी1 सीपी2 सीसीपी2, उसके बाद टी0 टी1 टी2, उसके नीचे सीपीयू 3s इंस्ट्रक्शन, इंटरप्ट्स, पोर्ट डी पोर्ट डी. और ये आपको तीन मतलब रटना पड़ेगी डायग्राम. और इसके पीछे हमने देखा था सीपीयू एएलयू मेमोरी. सो यही वही है, देख लीजिए एक बार. On power modes of PIC, power saving mode of PIC18 controller. So there are total 3 categories to manage power or for efficient power management. First one is run mode, ideal mode, and sleep mode. So let's see. Modes are sleep, 0, any. So first one is run mode, full power. A normal operation uses a main clock. So this command print run. And second is second run uses a timer 1 oscillator. RC run uses an internal oscillator and a lowest power run mode. Ideal mode, CPU turns off and peripheral on. Primary ideally peripheral uses the main clock. Secondary peripheral uses the timer 1 oscillator. RC ideally peripheral uses the internal oscillator. Sleep mode, everything off. The lowest power state wake up by interrupt, and input output ports are maintained state. Any difference between microprocessor and microcontroller? So let's see. So next question is differentiate between. So microprocessor, which is used in our laptop, and it's see the diagram: CPU, RAM, ROM, input, outputs, timer. So are all are in externally used. While on the other hand, microcontroller, CPU, RAM, ROM are inbuilt functions. So it is widely used in computer system. It is widely used in embedded systems. Like you can see the example of O1 microcontroller. Um, in O1 microcontroller is used. You set the timer after a time reach the specific time, it get automatically off. So these all are the part of the microcontroller. And while on the CPU, CPU is a part of microprocessor. So let's differentiate it. So microprocessor consume more power, while microcontroller consume less power. Circuit becomes large and circuit is small. Cost of entire system increases, cost of entire system decreases. High performance power disappear due because of external parts are inbuilt there, and cannot be used in compact system, hence efficient. Can be used in compact system, and hence it is efficient. It has a less number of registers, hence more operations are memory based. It has more number of registers, hence the programs are easier to write.